Hello everyone, we are back talking about Chapter 2, Lesson 6, Equivalent Fractions and Decimals. Those are just fractions and decimals, which are really the same thing, they're just written in two different formats. The decimals 0.75 and 1.2 in example 1 are an example of what's called terminating decimals. And looking back at example 1, if you see right here, 3/4 ended up, we did the long division, it ended up being 0.75, and then it stopped. It terminated, it ended. This is an example of a terminating decimal. 6/5, we did the long division, and then we got a 0 remainder, so it stopped at 1.2. So this is another example of a terminating decimal. And what it says is terminating decimals, those are terminating decimals because the decimals come to an end. Whereas the other problem that we did, the decimal 0.33333 is a repeating decimal because the decimal repeats a pattern forever. So that is a repeating decimal. And we had one over here in example 1 as well, right here, 2.333, and it kept going on and on and on and on forever. Now, we rounded it to the nearest hundredth, but what this is about to tell you is that if it is repeating, what you can do is you can write this little line on top, and that line means that it repeats forever. So let's look here. The decimal 0.333 is a repeating decimal because the decimal repeats a pattern forever. You can also write a repeating decimal with a bar over the repeating part. So here we go. 0.333, we can write that as 0.3, and the first part, when it becomes repeating, that's just where you put the line, and that just tells you, hey, it keeps on going 3 forever. Let's look at this one, 0.83333. Okay, so we write the 0, the point, the 8, and what becomes repeating is the 3. So we put the line over the 3 only, not over the 8, because the 8 is not repeating. This is kind of a fun one. 0.727272. In this case, 72727272 is repeating. So we put the line over both the 7 and the 2, and that lets you know that the 7 and the 2 are in the repeating pattern. You can even have ones like this, 0.1234, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, ... Well, what's repeating? Well, what's repeating is this, the 1, 2, 3, 4, that repeats every time. So that is this, the same as 0.1234. You write it one time and you put a line over the entire thing like that. So those are terminating. Terminating decimals stop, and repeating decimals repeat a pattern forever and ever and ever. Okay, let's move on to the next example. Example 2. So with example 2, we're going to be using mental math to write fractions as decimals. Now, how we do that is sometimes we can look at a fraction. First, let's talk about decimals. Whenever you have a decimal, let's say we have 0.12, okay? So this is the tenths place, right? And this is the hundredths place. So 0.12 is the same thing as 12 100ths. Okay? So in the same token, if we have 12 100ths and we have something written over 100, then we know that that's the same thing as 12 tenths hundredths. That's in the hundredths place. So this would be the decimal equivalent of this fraction. So, or we could do something like this. Let's say we have 0.7. Well, this is what? 7. This is in the tenths place. So this is the same thing as 7 tenths. So we could write it as 7 tenths. So if we know that we have 7 tenths, one way is to do the long division to figure out that it's 0.7, but also it's just to realize, hey, this is the tenths place and it's saying that there's 7 tenths. So you can just write it immediately 0.7 because 0.7 is the same thing as 7 tenths. So that's what we're going to kind of be doing in these next examples. We're going to be looking at the denominators and we're going to be seeing, hey, can we make this number into either a 10 or 100? And if we can kind of have a little bit of a mental math shortcut without having to do the long division. So when I look at this 5 here, let's look at 4/5, for instance. When I look at 5, I know that I can turn this 5 into 10 and 100. If I want to make it a 10, I just have to multiply it by 2. And if I want to make it 100, I have to multiply it by 20. But let's just turn it into 10 because that's going to just be easier. So how you do that is you just multiply the bottom by 2, and whatever you do to the bottom, you have to do to the top. And the reason for that is because what is 2 divided by 2? Well, 2 divided by 2 is the same thing as timesing something by 1. 2 divided by 2 is 1. And if you times a number by 1, you just get the same number, which is equivalent to what we started with in the first place. So this is a different form of 1. 2 divided by 2 is still 1. It just looks a little different. But the number that we're going to end up with at the end of this is actually going to be the same thing as 4/5. It's just going to be written in a different form. So first off, we know that 5 can become a 10 if we multiply it by 2. So we have to do the same thing to the bottom and the top. When we do that, we just multiply across and we get 4 times 2 is 8 and 5 times 2 is 10. Now we know that we have 8 tenths, and that's the same thing as 0. This is the tenths place right here, 8 tenths. So that is the decimal format of this number. And just ignore that line on the bottom. It's 0.8, just like that. Okay, so that would be this fraction written as a decimal using mental math. So let's go on to B, 37 over 50. So we're looking at that, and we want to know, hey, can we turn this 50 into a 10 or 100? Well, to turn it into a 10, it would be, we could divide by 5, but that's going to make this messy, so let's not worry about that. What if we wanted to turn it into 100? Well, that would be pretty easy because all we'd have to do is just multiply it by 2. Right? And whatever we do to the bottom, we have to do to the top because 2 divided by 2 is 1, and we can multiply anything by 1 and we get the same thing. So then we just multiply. So 50 times 2 is 100, and then 37 times 2, I'm going to have to do that multiplication. 7 times 2 is 14, carry the 1. 3 times 2 is 6, plus 1 is 7. So it's 74. So that means we have 0. This is the tenths place. That's the hundredths place right there. So it's 74 hundredths. So that is the decimal, 0.74, the decimal equivalent, using mental math. So now is the time where I want you to try it on your own. I want you to try to use mental math for Check It Out Example 2 and show your work. We have 3/5 and 18/25. So you want to try to see if you can make either of these, either a 10 or 100, and then make it into a decimal. All right, so now's the time. Go ahead and pause, work this problem out. When you get done, press play, and we'll see how you did. Okay, see you in a bit. All right, we are back. We are looking at 3/5, and what I notice about 3/5 is I can turn this into a 10 if I multiply the bottom by 2 and the top by 2. And 2 divided by 2 is just 1. We can do that. And then we just multiply. 3 times 2 is 6. 5 times 2 is 10. We have 6 tenths. This is the tenths place, and there's 6 of them. So our decimal equivalent is just 0.6. Okay, let's move on to the next one. B, 18/25. So, can I make this into a 10? It's over a 10. That's going to be very difficult. Can I make it into 100? Well, whenever I have like 25, I always like to think about like money and like a quarter and then 100 would be like $1. And how many quarters are there in $1? Well, there's 4. So what that means is I can multiply 25 times 4, and I will get 100. Because like $1 is like 100 cents, right? So I'm going to do that. I'm going to multiply this by 4 and this by 4. So that's just something I do. Whenever I see a 25, I just like to think of money in quarters, because then it's just, my brain just, I don't know, it's easier for my brain to think like that sometimes. So yeah, so we're multiplying both these by 4. We know 25 times 4 is 100. And then 18 times 4. We got to do the multiplication. 4 times 8 is 32. 4 times 1 is 4, plus 3 would be 7. 72, okay? So that means we have 72 hundredths. This is the tenths place. This is the hundredths place right here. So that means it's going to be 72 100ths. So the answer is 0.72. Okay? All right, I hope you got both of those right. If you did, great job, and we will see you next time.